Hello everyone. In this video, we will cover another important topic, which is perhaps the most useful concept in probability. This is known as mathematical expectation, or the expected value, or simply the expectation. It tells us what results we can expect on average if we repeat something many times. In other words, think of it as your best guess for what will happen. For a discrete random variable x having different possible values x1, x2 to xn, the expectation of x is defined as the summation of the product of these possible values and their corresponding probabilities. A special case of the expected value is the arithmetic mean, which is commonly known to us as simply the mean of some values. This is a special case because the probabilities are all equal. Now let's look at how we can define the expected value for a continuous random variable x having density function f of x. Here, instead of the summation, we use the integration. The expectation of x is often denoted by the symbol mu sub x or simply mu. Since it represents average of the values of x, it is often called a measure of central tendency. Let's look at an example. Imagine you are at a Carnival Game where you pay $2 to play and the game is rolling a die. The condition is that you will win $10 if you roll a 6 and you win nothing if you roll any number which is not 6, that is from 1 to 5. Now you ask yourself whether you should play this game or not. Let's see how expected value helps us finding the answer to this question. The expected value can help us decide by calculating our average winning per game if we played it for multiple times. So let's see the possible outcomes. If we roll a 6, we win $10 and the probability of rolling a 6 on a die is 1 by 6. We have solved this question many times in the previous videos, and similarly rolling any number from 1 to 5, we don't win anything, we win $0 and the probability for that event is 5 by 6. If we compute the expected value, we multiply $10 by 1 by 6 because that is the corresponding probability for this event, and $0 to 5 by 6. So we end up getting the answer or the expected value as $1.67. Now you can see that since we pay $2 and we are winning $1.67 on average per game, so you will lose about 33 cents per game. Now, what do you think should the answer be? Is it a good deal or not a good deal? So based on the expected value and our analysis, we can say that this is not a good deal. Let's look at some theorems that are very useful or handy when it comes to solving problems. The first theorem is if C is any constant, then the expected value of C of x is equal to C times the expected value of x. In another theorem, if x and y are any random numbers, then the expected value of x plus y is equal to expected value of x plus the expected value of y. In theorem number 3, if x and y are independent random numbers, then the expected value of xy is equal to the product of expected value of x and the expected value of y. So these are very useful theorems that we'll be using in the problems that we will solve in the coming videos. So I hope you get the idea about the expected value and its use. We will see more examples in the coming video to solidify our understanding of the expected value. I hope you liked this video. Thanks for watching and see you all in the next video.